Welcome to the introduction video of the Entity Framework port of SolidCP. In this video I will introduce you to the Entity Framework port of SolidCP and explain to you how we ported SolidCP to Entity Framework. So let's have a look. This is this solution here in Visual Studio. It's the solution of Web Portal and Enterprise Server combined. This is a new solution in the core VCF branch in a new version of SolidCP. It combines Web Portal and Enterprise Server, because in the new version you can run Enterprise Server and Web Portal in the same web application. So we have here this new project, SolidCP Enterprise Server Data. Basically this project contains all of the Entity Framework low-level classes for low-level access. We have a look at this project now. We have here a folder entities with all of the entity types of the POCO classes, entity classes that the database model uses. We can take a look at this, for example, domain is here. We have a POCO class with all the attributes to configure the entity class. And another thing to note is we support both .NET Framework for 8 and .NET 8. At the same time we support .NET Core and .NET Framework. So this code here, this attribute index is specific to .NET Core. And we should note we support migrations, and the migrations, they're here in the folder migrations, and we support different database flavors like MySQL, PostgreSQL, SQLite and SQL Server. And so all the different migrations for the different database flavors are in those specific folders. And one thing to note is that migrations are always treated by .NET Core. We don't do migrations by .NET Framework. Migrations are only run by .NET Core, so this is something to know. Okay, so we have this index attribute here, and it's only specific to .NET Core, but it doesn't matter, because the Entity Framework version, the running version, the runtime, it doesn't need to know about the index. Only the migration needs to know about the index. The .NET Framework version will also work without knowing about those indexes. So that's all the entity classes. Then we have entity configuration with Fluent API. We can look here, domain configuration, and we see here we have the Fluent API, a method configure, and this method it implements the Fluent API to configure the domain entity. And here we can distinguish between SQL Server, different database flavors. And here we have something special. This is SQLite specific code, and it does a collate no case, because we need this collate no case here, because SQL Server, that we used to use SQL Server in the versions before, and in SQL Server strings are always case insensitive. So as in SQLite normally strings are case sensitive, we need to change the data type of this property domain name to collate no case, so it's treated case insensitive. But we need this test here is core. We only apply this data type if we are running on .NET Core. We don't apply it on .NET Framework, because we only need this data type for the migration. The migration needs to know about this data type. So in .NET Core we apply this data type, and in .NET Framework we omit this data type. but since migrations are handled by .NET Core, the data type will be in place when we use the database also in .NET Framework. And here, as you can see, for SQL Server, we changed the datetime data types to datetime because per default .NET Entity Framework Core sets the date type of datetime to datetime 2. That's another datetime data type of SQL Server, datetime 2, and per default .NET Core uses datetime 2 as data type for datetime because it has some compatibility issues with the default values of datetime. But since the data model of SolidCP uses datetime, we have to specify this data type here specifically for the SQL Server. And here below, we define the relationships in the entity, and here we define the same relationships for .NET Framework. And then is another thing in the configuration classes are seed data. This class here, it has no seed data, but we're going to look at another class with seed data. You can see here below we have this region here, seed data, and here we can see that we initialize the database with the providers that need to be configured, and this is the seed data we enter for this provider. You can don't worry, you don't have to enter this seed data normally, as we created all these database classes by scaffolding the original database. And also, if someone changes the database model by modifying the old update DB SQL file, in the old version of SolidCP, we modified the database by modifying update DB SQL, and there we changed the database. And if someone still uses update DB SQL to change the database, if you want to update the Entity Framework classes according to the changes in the database, you need to scaffold the database. And we can do this. And you have to run this scaffold path in order to do it. We can try. I hope it works now. I'm not sure. I haven't used it quite some time. You can run the scaffold, and this will scaffold the database. By running this scaffold path here in the developer command prompt in the directory SolidCP Enterprise Server Data. The scaffold, it first compiles the project, and then it scaffolds the database. And let's see what it does. And scaffolding, the classes generated by scaffolding, they reside here. For example, the entity classes, the POCO classes. The scaffolder classes are here in the folder sources, and those classes, they don't get compiled. If you look here, build action is none, so we don't compile the scaffolder classes. And after scaffolding, you have to manually update the entity POCO classes according to the changes here in the source classes. But as we use version control, you're going to see which classes have been modified by the scaffolding. And then you see here a red checker mark when the class has been modified, and then you can update the real class, the real entity class here by hand. And also in the configuration folder, there's a folder sources, and here are the scaffolded sources of the scaffolded configuration classes. Okay, then we have some extension methods to the Entity Framework classes that we can use. For example, no, this is nothing we use. This is not compiled. We have some extension methods for the configuration classes. Where are the extensions? Here. Here, entity type configuration. This is a quite huge extension, and we have implemented this class in order so that we can switch between .NET Core and .NET Framework, so we can use the same class, the same configuration class for EntityFramework Core and EntityFramework.NET Framework. And here you see we have the properties where we can check what version of database we are using in the migration, and then we implemented all the classes, all the methods of the model builder class, of the entity type configuration. And so in normal entity framework usage, you have the configuration classes a little bit differently, but it's straightforward to understand. You can here in the configuration, we can just look what methods are available by using IntelliSense. It doesn't work now. There's no IntelliSense now, so you can just as usual use those methods. And there are two special methods, core, and those methods on the core, they are direct. They refer to the entity type builder, of .NET Core. And as you see, those versions are not available in .NET 4.8, but in .NET 8 they're available. And then we have NetFX, and those methods are only available in .NET 4.8. Those are the specific methods, all the methods that are available in .NET 8. And the methods in Core are all the methods you have available in .NET 8. And most of those methods, they are directly available without Core or Net. So for example, has, you can see here all those methods are available in both in .NET Core and .NET FX framework. Yes. Okay. The scaffolding uses code templates, and those code templates, they are implemented here. One code template for the entity framework, and then a code template to implement the seed data, and a code template for the DB context and for the configuration class. And then we have here the class that implements the scaffolding. Internally we had to program a little bit, so we also support scaffolding of seed data, because seed data normally is not supported for scaffolding in the original entity framework core. And then a program so we can run the scaffolding. As you can, we can take a look at this batch script that does the scaffolding. Let's collapse those here. Here the scaffold path. It actually only runs this project as a .NET program and runs the target scaffold from the project. And if you look at this target here in the project file, here this is this target. It executes .NET EF DB context scaffold, and then the connection string This is the connection string, and the connection string for scaffolding is defined in this project here, in the project file, under scaffold connection string. This here. This is the connection string used for profiling. I'm not sure if it also would work with a MySQL database scaffolding, but usually we only do scaffolding from a SQL Server database. Maybe it would work with MySQL, but I'm not sure about that. Yes, and then we have the migrations. If you need to add a new migration, then you need to run this script here, migrations add. It asks you for a name of the migration, and then it does all the migrations for the different database flavors. And then after it has created the migrations, it creates an SQL script to install the database. And then theoretically it would also create a bundle exit to run the migration on a database, but this keeps on bringing an exception. It doesn't work, and it's a bug in core in EntityFramework core migrations, and so I commented it out, this bundle creation. At the moment there's no bundles to migrate the databases. But this is a little bit of a problem, because for SQLite is special that the SQL code generated for SQLite is not idempotent. That means you cannot run it on an old version of the database, and it doesn't automatically update the database to the latest version. It can only be used to install a database from scratch, because SQLite does not support if statements in the SQL. So the SQL script for SQLite, it cannot treat condition and conditional execution, so it cannot upgrade an old version of a database to the latest version. It's impossible. You can only do this by running directly the .NET EF command on that database, like you do here in the add migration. You would have to manually run some command like this to the database and upgrade it. So we don't support upgrading SQLite databases at the moment, because we cannot create a bundle script to upgrade the database. The other databases, you can just install the script, and the script will automatically upgrade an old version of a database to the latest version. You just need to run this script here on the database, and that's also what the installer does. It just runs the script specific to the database. Here's the SQL Server script. And those here are all the migrations so far. There's quite a lot of migrations, and this is a little bit of a problem. If you have a small bug in the database you need to fix, you need to create a migration for it. And you could combine the migrations later on to a single migration, but as soon as you have installed the database in a production server, and as soon as you have published the migration to the SolidCP GitHub repository, it's a problem to delete the migration, because other people might have installed this migration, and if you remove a migration, then you won't be able anymore to upgrade a database that has this migration installed. So probably it's best practice to just add migrations, and then those folders here will become huge, filled with little tiny migrations. But it's risky to combine those migrations into a single migration, because someone might have installed the migration, you're combining into a bigger migration, and won't be able anymore to upgrade his database. Yes, and here are two scripts, one to add migrations and one to move the last migration. This migration remove always will remove the last migration. And this is also a little problem in working with GitHub. If someone works on a branch and introduces a migration, and someone else introduces another migration on the same version of SolidCP, then those two migrations are not compatible when merging. So when merging, you should remove the two migrations and introduce a single migration, or remove at least the new migration from one version and then introduce the same migration in the other version. But this is a little bit tricky to do, and it's not obvious how to do this, so it's better to remove both migrations. And as a little help in this, when introducing a migration in EntityFramework, EntityFramework also always uses this snapshot as the snapshot of of all the current migrations. This is the snapshot that is represents the state of all the current migrations, and EntityFramework uses this snapshot to create a new migration if you add a migration. And so in order to be able to combine those migrations into one migration, if you publish a SolidCP version by deploy release or deploy debug script, if you create a SolidCP release, the deploy release script will always create a backup of the snapshot for this version here, for 149. This is the backup of the 149 version. When you create a version of SolidCP, it always takes a backup of this snapshot here and stores it with the version number in this file here. So you can revert this file here as a snapshot, and then you can create migrations based on this version of the snapshot. But still, there can be problems when multiple people are introducing migrations in parallel. So this is something I don't know how to do this better, and it's a little bit of a problem if you merge two branches with different migrations. Yes, so those are the migrations, and here are the legacy script. Here is the install dbSQL and update dbSQL from the old version of SolidCP that didn't use EntityFramework, so those files are still here. And this update dbSQL, it's almost compatible to the new version no, I think it is compatible to the current version of SolidCP. So instead of running the SQL Server install, instead of running this script here, install SQL Server SQL, you can still use update dbSQL, but I'm not sure if it always already implements the last version. We can see this. You can check this if it implements the last version. No, at least those three migrations are not included in update SQL. So you can run up to state SQL on a database, but you still have to run install and then database version SQL on the database to upgrade it to the latest version. So it's better to directly run Now if you upgrade an old version of a database that not the core VCF branch, you first have to run update dbSQL, and next you have to run install SQL Server SQL. Install SQL Server SQL will not be able to upgrade an old version of the database automatically, because there's no entity migrations table in the database, so the install script, if you use this install script here, it will think it's a new database, a fresh database, and this will conflict with the existing table, so it won't be able to upgrade the old version of the database. It can only upgrade databases already using EntityFramework. So the process of upgrading an old version of a database is to run update SQL first, and then this here install SQL Server SQL. Yes. And here is the DB context class we use. It's a class that it's not actually, and it doesn't inherit from the EntityFramework DB context, but it has some of the properties and methods of the DB context, like here, like save changes, and it encapsulates an EntityFramework DB context in this property here. And this DB context base, this is the base class of the EntityFramework DB context. It inherits from DB context, from EntityFramework DB context, or depending on EntityFramework core or EntityFramework, it uses the corresponding context. And here, this class is actually scaffolded. The scaffolder class is here, a DB context base source, and you have, if you scaffold the database, you have to take the changes here in source and introduce them manually in this DB context base. And what it does the method, the model configuration. Here are all the DB sets. All the DB sets are defined here, and then on configuring, depending on the database flavor, it calls the database methods, the database flavor methods on the builder, and then there's the configuration, and it calls apply configuration on the configuration classes. And then this is a part, the DB context. This is the DB sets on the DB context, on the parent DB context class that encapsulates the DB context base class. And this is a parser class, but actually I think we copied those. No, we did not copy those properties. This class is partial, the DB context, and we just copied this DB sets here. This is turned off, this compilation switch, so it doesn't compile this change, but we copy this here by hand into this file here, context DB context sets. And here are all the DB sets defined that the DB context supports. And it's a little bit different than in base. In base you just have a DB set, and in the base class you just have a DB set and then a getter and a setter, and that's the standard way how you do it in EntityFramework. You have a DB set for provider and then a getter and a setter. But here in the parent DB context, you have to define a DB set and then a local variable of the DB set, and then initialize it with this method. You have to configure the DB sets in this manner here. It's a little bit different. So that here is the place where you would put a new DB set of the database. And then this is, I don't know what this actually is tonight. This is some stuff we need for compatibility with with connection strings, and yes, I think that's it. And then next, that's it about this project, Enterprise Server Data. Then we have changes in Enterprise Server Code. And first of all, as we now need a DB context to connect to the database, we have changed all the static methods in the DB Enterprise Server Code to dynamic to instance methods, because we have implemented it like this, that each web request over that comes in on Enterprise Server, for each web request we create a DB context, and we use all this DB context all through the web request. So we don't create a DB context each time we need a DB context, but we create a DB context per request. And this works like this, that we have every controller. There's a lot of controller classes here in .NET code. Like for example, packages. We have package controller, and we have web server controller. All those controller classes, they inherit from controller base. And in the enterprise server, in the web service classes, as we see here, we always call those controllers. You can see this here. For example, this method, get raw exchange organization page, it calls a controller class. And so since this controller class now it inherits from controller base, the controller base will create a DB context that's always used in this controller class. And so there will only be one DB context throughout the whole web request of this web method. And if you need another DB context, sometimes this is the case if you are querying a table from the database, and then you need to change from, we'll look at an example. There's places where we do need another DB context, a second DB context, and this, no, let's explain that later on. First of all, this is the data provider CS file. In this class, there's all the data, database access code is encapsulated in this class. So it's a huge class, and let's have a look at this class. And this class, it implements all the database access code. And before EntityFramework, this class used store procedures on SQL Server. So let's look at this method, for example, set system settings. We have here if use EntityFramework, and this is an if statement in all of those methods that distinguishes between usage of EntityFramework or usage of stored procedures for SQL Server. Here's the old version of that method. It uses SQL, and it uses a store procedure to implement this method. And this only works on SQL Server because the store procedure is only implemented on SQL Server. And there's the new version of that method that is used when we use EntityFramework to access the database. And this is the EntityFramework version of that method. And as we can see here, it starts a transaction, a database transaction, then it deletes the old system settings, and then it creates a new setting and adds the setting, and then save changes, and then commits the transaction. That's the EntityFramework version of this method. And I placed the source code of the store procedure in a comment here. All those methods have the source code of the store procedure in a comment, so you can see what the store procedure did, and if there's some error in the EntityFramework version implementing this store procedure. So we have here the source, that's the SQL version of the store procedure, and then we translated all this source into an entity framework version that does the same thing with entity framework. As I said, sometimes we need a second DB context, and so we do this by using a special property of the DB context. Let's go up here. And this class DB provider, I need to mention, it inherits from the generic DB context from the enterprise server data project. So it's actually a DB context. You can call save changes on this data type. You can access all the DB set properties of this data provider. It's all there. You can treat it like this class like a DB context. So if we need a second version of the second DB context, we use this using this method. We use clone, this method, the property clone, and it will create another version of the data provider with the same connection string, so we can have a second DB context to access the database. Why we need a second DB context? Let's have a look at the code. I explained. No. Find our references. As we see here, we have a query here. We query the comments table, and then we have some where class that filters the query, and then we have another filter, but this filter is actually a method. If we look at the original SQL, we can see here this filter DBO. It's another stored procedure implemented as a filter, and this store procedure, it's a second store procedure that is called by this filter here in this where clause. So what we did, we have implemented this check user parents as a procedure in Entity Framework. We can go and have a look at it. This is a usual Entity Framework procedure that uses Entity Framework, and it will check if the user ID, if our owner ID is a parent of the user ID. So problem is, we cannot use this Entity Framework method in the filter above here, because this filter is run on the database, and this filter here is run on the client side because it's a .NET method. So we need to run it on the client side, and we can do this if we take the original query that's run on the database, and we convert it to an enumerable, and then the part after as enumerable is run on the client side. But since we take as enumerable on the client side, this makes an enumerates the query that was run on the database and uses a DB context. And then when we use the DB, again on the client side, it complains that the database connection is already in use. So we need to use a clone DB context to access this check user parents. Otherwise, Entity Framework will complain. We could also solve this differently, and sometimes we did. We could here, instead of as enumerable, we can say to array, and the to array, it will load all this previous query into an array, and then we can use the same DB context. We can omit this clone. But enumerable, it will also work for very huge data, and to array, it's problematic if we have huge data sets. It will take a lot of memory, and as enumerable, it will use less memory. Okay, and then if you access the database like this data provider class in the controllers, let's have a look at the some controller. you access the database like so. You just say database and then you call a method of this data provider class. It used to be called data provider when we accessed it, but now in this controller based method we changed the name from data provider to database because it's accessing the database. So that's how you access the methods of data provider of the data provider class. As we can try here, we can, as database is also a DB context, data provider is also a DB context, we can also access the entity framework DB sets like this. We can access the methods that the DB provider introduces, all the database access methods, but we can also access the DB sets. This is a DB set it's because it's a DB context, we can access the DB sets directly, but you shouldn't do this. You should always encapsulate your database code into a method in the data provider class. You shouldn't access the data DB sets directly in the controller classes, but you could if you wanted to. And then we also have save changes, and so we can also do this here. And another thing to note is that if we implement new functionality in the database, it's actually favorable to only implement the new functionality using EntityFramework and not in a store procedure. Because if you implement also store procedure for SQL Server, then the store procedures, they are they usually in the past, the store procedures, the code of the store procedures was all here in update DB-SQL. All the store procedures resided in here like this. Now create procedure, and if was a store procedure. And in the new version, the store procedures, they reside in a migration. Here initial create, and here initial create store procedures, and it's a huge file. It's a bit cumbersome to maintain. So if you want to introduce a new store procedure, you have to make a migration, and then the migration up. In the migration up, you have to introduce the store procedure like this here. But this here, it's a huge SQL that implements all the store procedures in the database. And then below, we have the drop code. That's also a huge SQL that drops the store procedures. And if you want to introduce a new procedure, new store procedure in SQL, you have to create a new migration by hand, and then in the up method, you would have to have here an SQL method and then create procedure, and then in the down method you have to have a SQL method drop the procedure, and like this you could introduce store procedures. But as it's cumbersome to maintain and everything, we recommend new functionality only implemented with EntityFramework. But it has some drawback. EntityFramework is slower than store procedures, because EntityFramework, on the first time you run a query, it always has to compile the query to SQL, and sometimes this is rather slow. This compilation of queries into SQL can be rather slow. And it does cache the SQL, and on the second execution of the same query, it's faster. It's the same speed as SQL, but first it has to always compile the queries to SQL, and so it's slower than store procedures that directly use SQL. So if you want to really have a fast version of your new functionality, you might also implement store procedure, but we don't recommend to do so because it's hard to maintain the code. Yes, and what else? Yeah, maybe something to mention also is a concurrent execution. There's here the task controller, and this task controller is called concurrently in the background. So the database access has to work also concurrently, and it's not implemented here. For this we have a method on the data provider, or on the controller base maybe. I'm not sure. Let's have a look. It's called as async. No, it's not implemented here, so it's here. This is this method here as async. If you want to use a controller concurrently in another thread or in the background, you have to create a copy, a clone of the controller with this method as async. And we can hear how this is implemented here. For example, in Task Manager, the Task Manager does run tasks in the background. So when using the task controller, we create first a copy of this is Task Manager, so we create a clone of the Task Manager as with the method as async, and then we call the task controller on this clone of manager. We could also call it directly like this, because Task Manager has all the properties inherited from controller base, and controller base implements all those classes we had. So you can call them with an associated data DB context. We have this here, the controller base. It implements all the classes we had, all properties for all the controller classes we had. Like here, this hosted SharePoint server controller, it's now a property of the DB controller base, and it's protected, and you can access it in every controller class. So we could also, we can look at this, what we have here. We have all these controllers here, all the controllers that use a database, that used to access the database, so they have a shared DB context, all those controllers per request. So we call this here with the async manager. So if you want to call a controller concurrently from another thread, you have to create a copy of the controller with this as async method. Yes, I think that's it. Yes. Yes, we could explain also. We have in the past the DB access worked like this, that the data provider called the stored procedures and returned a DB reader or a data reader or a data set, an ADO-net data reader or data set, and then we had a class object utils that was, this class here was used to copy the data from the data set or data reader into objects, into .NET objects. And we enhanced this class object utils. This class used to be in enterprise server code, not in data, but now it's residing in data. We enhanced this class so it also supports EntityFramework versions of data reader and data set. So in order to support the old infrastructure, we created this class Entity Data Reader, and this class it's a data reader you can use in place where you expect a data reader, but it supports a set of entities, an entity set. And there's also an entity table for use in a data set, so we can also return data sets that support entity classes in the data set. Yes, I think that's it for now. Thanks for watching. I forgot to mention one thing. In the panel you can configure usage of EntityFramework here in the system settings. When you have an SQL Server database running the enterprise server, you can configure here in the debug settings, you can tell the system to use EntityFramework for database access. Here it's grayed out. This option is disabled because we have a MySQL database as a backend, and MySQL always uses EntityFramework for database access. So at the moment this is disabled. But if you use SQL Server as a database, you can check here, so it uses always EntityFramework for database access, but this is only for debugging. And if you check this option here, then when the system uses EntityFramework as for database access, you can see here below in the footer of the website, you see here also a checkbox, use EntityFramework for access, and this way you can always enable or disable EntityFramework, and you can debug the EntityFramework specific code. That's for debugging. That's what I forgot to mention.